Welcome back. In this video, we're going to talk about arcs and chords. As we spoke about earlier, we spoke about the different parts of a circle, right? So a quick review, an arc is part of the circle. So here, for example, the arc in the top circle would be, like this section is an arc. And this section here is an arc. A chord is a line segment whose both endpoints are on the circle. Sometimes it's a diameter, sometimes it's not. So as you can see here, this is a chord because both endpoints are on the circle. Now that chord intersects the arc, and whatever angle that creates, let's say that this creates an angle, let's say that this angle here that it intercepts is, I don't know, let's say 100 degrees. If this other arc is also 100 degrees, what we're going to start off by is that if the arcs are congruent, then the segments by default will be the same length. Whatever this length is, it'll match this length. And vice versa, the converse is also true. Let's say that we have two chords that measure the same length. If I know that this length is, say, 10 centimeters, and this one is also 10 centimeters, since they're both the same length, then that means that the arc that they create, or that they intercept, the angle that they intercept, that angle will match the other one. The angles will by default be also congruent. Okay, so let's start with this theorem 10.2. Let's do a few examples. As you can see here, we have segment MN is intersecting this chord. Sorry, this chord is intercepting that arc, and this is arc MN. This arc is going to be congruent to arc PQ because both of these are congruent. So we can assume that segment MN is going to be equal to PQ. Since the angles that are intercepted are the same, the segments are the same. So we just set up an equation where the segment 26 equals to the other segment, 3x plus 5. And we just solve for x. Move 5 with the other side. We're left with 3x equals 21. Divide both sides by 3. And we're left with x equals 7. As you can see in this other example, we have arc WY is 143 degrees. And we're given that this other arc on the other side is 2x minus 1. Since they're both the same chord, the same length, they're both 18, I can also say that the two arcs on the outside are congruent. So 143 degrees must equal the other arc, 2x plus 1. Simple as that. The arcs are congruent, the chords are congruent, and vice versa. If the chords are congruent, then the arc measure will also be the same. And once we set them equal to each other, we solve for x. This is 142 equals 2x. Divide both sides by 2. X equals 71. Let's talk about another theorem. Here we're talking about theorem 10.3, talks about what happens when we bisect an arc. Bisecting an arc and a chord. So, if the diameter or the radius is perpendicular to the chord, then it's going to bisect it. And the key word here is bisect. If you remember from like back in September, bisect means cutting it into two sections. And the key word here, perpendicular, means that they intersect at 90 degrees. So let's say that we have a radius or a diameter that intersects the chord at 90 degrees. What this theorem is talking about is that if it intersects, whether it's the radius or let's say we extend this as a diameter, if it intersects the chord at 90 degrees, it's going to create two congruent segments. It means that this segment from here to here will be the same length as from here to here. And since the chord is getting cut in half or into 2 equal sections, the arc as well. This arc will also be cut into 2 equal parts. Let's do this in different colors. From here to here, this section will be the same measure as this section. The perpendicular part cuts everything into 2 parts, the chord and the arc. So let's look at an example. In circle S here we have measure of PQR. Arc PQR is 98 degrees. So from here to here, all of this measures 98 degrees. I'm struggling with this marker for some reason. This whole thing is 98 degrees. Since this is intersecting at 90 degrees, I can find the measure of PQ, which is just part of it. What is the measure from here to here? Well, the entire arc, 98, is going to be cut into 2 equal parts. So all we have to do is do 98 divided by 2. And that gives us 49. So the measure of PQ is 49 degrees. If I wanted to find the length of this segment, since this segment from R to T is 6, we can also say that this piece would also be 6. They're both going to be congruent. In this next example, we have a stained glass window that has a diameter of 30 inches, and the chord KM is 22 inches long. Notice how the diameter is intersecting the chord at 90 degrees. So we want to find the length of JL. What is this measurement? Let's call this, JL, not JK. We want to find this length. Let's call it X. Now, notice how the diameter is 30 inches, which means that the radius, the length from here to here, the full length, would be 30 inches. Anywhere in that, 15 inches, because the diameter, we can cut it in half. Any direction from the center to the edge of the circle would be 15 inches. So let's measure this piece 15. I also know that the chord measures 22 inches long, which means that half of the chord, instead of the whole thing being 22, we know half of it is 11. As you can see, we have a right triangle with 2 given sides. To find the missing side, we use Pythagorean theorem, and that's just 11 squared plus x squared equals 15 squared. This gives us 121 plus x squared equals 225. We subtract 121 on both sides. X squared equals 104. We square root both sides to solve for x, and we can round this to like the nearest tenth or the nearest hundredth, so we get the square root of 104, which is about 10.2 inches. I used what I knew about the chord and the diameter, and I drew a right triangle and I found the missing piece. In this next section, we're going to be talking about the length of chords when they're the same distance from the center. As you can see in the theorem here, it says in the same circle, or 2 congruent circles, right? If we have 2 chords that are the same distance from the center. So let's say that I don't know this length of this chord. I have a chord here. Let's call this A. Let's call this, I guess I can't use A. Let's call this BC. And I have another chord over here called DE. If both chords are the same distance from the center, let's say that this distance here, that length is 5, and this length is 5. Then that means that the segment BC is going to be equal to the segment DE. And if you think about it, if we had a different circle, let's say that we have a circle over here. If I had a chord that was closer to the center and one that was further away, notice how those two are not the same length because the distance from here to the chord and the distance from here to this other chord are not equal, right? But when they are equal, as we can see over here, if they're both the same distance from the center, then they're going to measure the same length. So let's try some examples here. I know that WX and XY are both 22. So WX and XY, they both measure 22. Since they're the same length, what do we know about the distance to the center? We know that the two of them must be the same distance. The distance from here to A and from here to C should be the same amount. So we can set up our equation where 5x is equal to 3x plus 4. And then we can just solve for x. Subtract 3x on both sides. 2x equals 4. Divide both by 2. X equals 2. Now we're really interested in finding the measure of AB. What is the length of AB? Which is right here. AB is just equal to 5x. So when we plug in our value, we get AB equals 5 times 2, so the segment equals 10 units. Let's check out this next example. From this picture, I can see that they're both the same distance from the center. They're both 8 units away from the center, which means that these two segments, QP and RS, are going to be the same length. Notice how PQ is equal to 3x minus 4 and RS equals 14. Since they're equal to each other, we set up an equation by saying 3x minus 4 is equal to 14. The two lengths of the chords are congruent. And then we just solve for x. We move forward to the other side. 3x equals 18. Divide both by 3. X equals 18 divided by 3, which is 6. The key thing here when we're looking at these different principles and these different examples, right, is what two things are going to be equal. If the chords are congruent, then the distance between them are congruent. If the arcs are congruent, then the segments that create those arcs are going to also be congruent, right? Focus on what two things are congruent, set up the equation, and then just solve for x. So here are our last few examples that we can look at. The key thing here is the idea of what we're working with, right? What is it that we're working with, and how do I set up some sort of equation to solve? In this first example, I'm trying to find the value of this arc. Now, since there's two chords here, LM and PM, and they're both congruent, I can say that these two arcs created are both going to be x degrees. Since the total degree measure on the outside of a circle will always be 360 degrees, I can say that x plus 106 should equal 360 degrees. So we combine like terms. We have 360 equals 2x plus 106, and we just solve for x. Subtract 106, subtract 106. 360 minus 106 gives us 254. And when we solve for x, we have 254 divided by 2, which is 127 degrees. The thing that we spoke about when we spent so much time about triangles is that all triangles add up to 180 degrees. Well, here we're dealing with circles, so they all add up to 360. Let's look at this next example. I can see from the picture already that chord or segment JK is going to intersect at 90 degrees. So I already know that it's going to cut that segment LM in half. So the diameter length is 18, LM is 12. Let's label a few things here. LM is 12. Since it's cutting it in half, I can say LM is 12, which means this piece is going to be 6, and this is going to be 6. Measure of arc LM from here to here, the measure of the whole arc is 84 degrees. Now, this segment is cutting it in half, which means to find measure of the LK, which is this component right here, it's cutting it into 2 equal pieces. Right? This and this are going to be congruent. So all we have to do is take the entire degree and cut into 2 parts. 84 divided by 2 is 42 degrees. Now, to find the measurement of HP, we know that the diameter, which is this section, let's change the label here a different color. To find this length, HP, we'll call this X. I know that the radius, since the diameter is 18, I can say that the radius is 9. So I have 9, this whole thing, if I wanted to label it was 9, from here to the edge of the circle is also 9. And here, as you can see, we have a right triangle that measures 6, X, and 9. We have this right triangle that we're working with. Again, since it's a right triangle and we have 2 given sides, we can use Pythagorean theorem. Had we know an angle or something else, we could do SOHCAHTOA. We're dealing with Pythagorean theorem. So we have x squared plus 6 squared equals 9 squared. That gives us 36 is equal to 81. Sorry. Plus 36 equals 81. Isolate the variable. (81 minus 36 is 45. And to get rid of the square root, to get rid of the square, we square root it, and that gives us 6.7. 1, because we're dealing with the nearest hundredth. Alright guys, I hope this has helped. Please let us know if you have any questions. Don't forget to like the video and subscribe if you haven't already. And as always, we'll calculate later.